Hey everybody, welcome back. In this activity, what you're going to do is to use a pivot video, but you're going to use it in a super fast and direct way that fits with the problem solving skills you guys developed before vacation. So what I'm going to do is to show you a screen, it's a screen grab actually, of one of the pivot videos. And what I want you to notice is that we've got a bunch of balls have been thrown up in the air, and you can see this guy's hand down here. This is really cool what they did. They threw a bunch of things up in the air and they synced the videos perfectly so that the maximum height for all of them was the same. The release point was the same. They did a great job with this. So what we're going to do is zero in on this green ball right here. And what I want you to notice is that we've reset the timer when this right there indicator says we're at the very top of the motion. So what you're going to see me do right now is to go to pivot, open up the video, and walk you through the steps you're going to use for one of the trials. So you're going to copy down what I do, and then you're going to use the video to get 2 more data points so that you can do the same kind of analysis and improve your problem solving skills and end up with a good result. Okay? So I'm going to take you right into the video and show you how it looks. Okay, so here's our pivot video. The way this whole thing works is they did a beautifully synchronized throw where they had a lot of trials and they gave people a lot of chances to get these right. And what they've done is gotten their release points nailed down, and they've got the highest point of the ball's trajectory nailed down. You see we're moving upwards. We're going to want to zero in on that moment just between moving upwards and moving downwards and zero in on that. And so you can see the video replaying. So the ball slows up on the way down, speeds up on the way back down. And so I'm going to pause that. And to do the lab, what you're going to do is drag this guy to frame 664. So how do we know which frame that is? As always, grab our timer tool and drag it off to the side. We're focusing on the green ball. What we want to do is get to frame 664. And that should be the space where we are just right at the very top of the motion. So that's the very peak. And then you hit reset. So what I'm going to do is show you how to get data for the first trial. It's really fast and it's dead simple. What I'm going to do is drag this guy forward and let the ball fall from the very top until it just kisses the 20 centimeter mark. Now for me, that looks like it's 0.2033 seconds. So I'm going to work with that. I'm going to write that down, and you're going to see me use that to do an LEPS type calculation, and I'm going to step you through it so you can do the same kind of thing when you get to your lab. So what we've done is we've taken the data that we got from the video and we've turned it into an LEPS problem. We're going to know for sure that with all the drops we're going to do, we're starting from the top. So the top speed is 0 centimeters per second, also known as 0 meters per second. The V2 isn't something we know yet, but we know for this trial that we dropped the ball 20 centimeters, so we converted it to 0.2 meters. And then finally, we know that our trial said that it took the ball 0.203 seconds to reach that 20 centimeter mark. So you're going to do the same thing 2 times as this, just with different numbers. What we need to do is figure out the V2, and we need to figure out the acceleration. So in good old LEPS style, the very first thing we're going to do is we're going to look at our formulas. We have D equals V average times T, and that turns out to be the one we want to use first because we have the distance and we have the time. We can use it to figure out the V average. So that's what I'm going to do. I'm just going to do the algebra. V average equals D over T. And we're going to go ahead and plug in. We get 0.2 meters over 0.203 seconds. And that gives us an average velocity of 0.985 meters per second. Okay? Second thing we're going to do is we're going to use the fact that the average velocity, the V average, is equal to V1 plus V2 over 2. So what does that tell us is that since we know V1 is 0, we can use the fact that we know the V average right now, we can multiply it by 2, and we can figure out what the V2 was. So this gives us that V2 is equal to 2 times the V average that we just figured out. So we're going to go ahead and do that, and then we'll finish this up in the next frame. So V2 is going to be 2 times 0.985 meters per second, and that turns out to be, I think it's 1.97, yeah, 1.97 meters per second for our final velocity. Okay, so that's nice. We've got the V2, and that puts us in a really strong position because we've got the V1, the V2. Now we can easily go and get the acceleration. So we'll just get that on the next slide. Okay, so we just did a little copy paste here with our slide, and we've got now the V2. It's 1.97 meters per second, and all we need to do to figure out this acceleration is just use what we know. A equals delta V over delta T, and we'll go ahead and plug in what we know. Delta V is just 1.97 minus 0, 1.97 meters per second. We knew that this took 0.203 seconds, and there we go. Turns out to be 9.71 meters per second. So this green ball dropping through air, darned close to the actual acceleration of gravity of 9.8 meters per second. Anyway, that's one of the trials. You know what to do with the other ones. Just go ahead and replace this number and a time and get a little practice with LEPS. Bring your questions to class. See you soon. Take care. Bye-bye.